Hello everyone, welcome to the GeoEcologist. I'm Dr. Krishnanand and you have been watching my videos on various topics of geography, environment and hydrology of late. So if you have not checked the earlier videos, you can go to our playlist section and check for yourself our earlier content. And this is the ongoing series on hydrology. So in today's session, we are going to learn a very important and interesting aspect of hydrology. That's going to be river discharge, its various factors, and of course, the most important thing, the various techniques of measurement of river discharge. So watch the video till the end. It's going to be really interesting. And if you're a new user to this channel, please do subscribe our channel. You can also join our channel if you really want to support us. And of course, please do share these videos to more and more people. So now let's learn. So as you can see, our topic is measurement of river discharge, its various techniques and classification as well. So before we go ahead, there is one important announcement and information for you that if you want to check our online courses, you can visit our website, TheGeoecologist.com. And for the content that you're watching in our YouTube videos, like for this content, if you want, you can go to our website, that is geographyebooks.com. So on geographyebooks.com, all our lectures as it is posted as the ebooks PDF for you to download. Now let's come to our topic, river discharge and hydrology, and understand it. So the first thing to understand in river discharge is the definition and importance. Why do we need to learn river discharge? So what is river discharge? Is basically flow of water in a river or a stream channel, which is expressed in particular way. What is the expression here? Volume of water passing a particular point in a given time period. So you see, if this is the river, right, and there is a volume of water passing through this particular point. So if we have to define a point from where this is passing, so this particular point is important over a given time period. So you see, cubic meters per second. So this is the unit here. So we defined it at this particular point. Now understand that why is it important? So its importance lies in its practical application. That is what you're looking here. So basically, for better understanding of the water and its application, that is, we're talking here, management of our water resources. So management of water resources would definitely include the understanding of river discharge, forecasting floods, designing hydraulic structures, and of course, maintaining ecological balance in the riverine systems. That's very important, especially for a country like ours, which is full of all river, right from Himalayan river to peninsular river, isn't it? So let's understand it more. So before we go into the actually techniques of measurement, the first thing is to learn about this thing called hydrograph. And many of you have asked the questions about hydrograph and its interpretation in the earlier videos as well. So now let's understand it carefully. What are hydrographs and what is its usage? So whenever you measure river discharge, and how do you illustrate it? So hydrographs are used to illustrate discharge measurements. So if you observe, this is a representation of hydrograph, and these are used to show annual discharge patterns of flow in relation to climate. So what kind of climate is there and what kind of discharge is there? So climatic parameter, if you see, here is the rainfall in millimeter. You see that? And then you have this rainfall given here in the bars, and there is discharge in Q6 or Qmex. So if you observe here, what is the thing? With rainfall, how this pattern changes and varies, right? So when there is low rainfall, if you observe till the point, there is a thing called base flow, right? And when the river actually is full of water due to heavy rainfall, when it's peaking up, you observe there is this rising limb. So then there is overland flow, through flow, then there is bank full discharge, and at the highest, you see storm hydrograph. So here is the peak discharge when rainfall actually peaks. But you see there is a lag here. Rainfall is peaking here at this particular junction, but peak discharge is observed here, right? So this is what we call as lag time. So these are certain important things here to be observed: base flow, overland flow, bank full discharge, lag time. These are some terminologies that you should remember. So if you observe over a short term, if you observe, flooding is very important. And every year, monsoon, pre-monsoon, and these days, because of the changing anomalic conditions, if you observe in climate, we have a lot of storm hydrographs every day. So you observe that wherever there is a flood, you observe these kind of hydrographs, and they cover relatively short time period as well. Not just generally we use it for annual, but for short time, usually hours or days also we use it. So storm hydrographs are something which talks about this investigation and the relationship between a rainfall event and a discharge. So if you see that cyclone Remal happened, and during this you had these streams flooded, right? So if you go to northeastern region in India, you'll see streams flooded. So we have stream hydrograph like this, storm hydrographs. So there you observe that what is the lag time and what all concepts are there. So this is why in hydrology we understand all these topics. Now come to the factors. So if you observe, there are human factors that are affecting storm hydrographs as well. So let's understand this range of human factors. So if you observe in the diagram also it's mentioned, and here in the text you can observe. So what is it? Drainage systems have been created by humans, leading to shorter lag time. And shorter lag time means basically high peak discharge, as water cannot evaporate or infiltrate into the soil. So it means what? If you have a shorter lag time, flood or flash flood that we call is more. The chance of flash flood is more if you have a short lag time. Remember, so areas that have been urbanized result in what? If you remember, the permeability is affected. So use of impermeable building materials does not let water to infiltrate. So what you see, increased runoff, and this is creating a lot of problems here in the hydrology. So here you will see that infiltration level decrease and surface runoff increases due to urbanization. So if you see the graph, you will see here there is a formula. Drainage basin discharges precipitation minus evapotranspiration, but plus minus changes in storage. So if you see in urban time period, what happens? The storm hydrograph after urbanization, you see here is the peak and here is this. So do you see this lag time is very less, right? But here if you see, this lag time is more. So if you have less lag time, it means that river channel is flooding very fast, right? So these kind of interpretations are to be drawn. Now come to factors influencing river discharge. So factors influencing river discharge, let's understand point wise. The first is catchment area characteristic. It all depends upon how much is the size and shape of the particular river. So large catchment areas can collect obviously more rainfall precipitation, leading to higher discharges. Then you have land use pattern in the area. So remember, urbanization increases runoff, while forests and wetlands enhance infiltration, so reduces discharge. That's why we say keep planting trees, remember. And soil type is also important. Remember, if in the soil geography, in biogeography lectures, we talked about permeability and porosity of soil. So permeable soil increases infiltration, right, and reduces surface runoff and moderating discharge. So the first factor is this characteristic of catchment area. Second is your precipitation. Now you have seen, because of the impact of climate change, there are seasonal anomalies happening. So most of the areas are experiencing cloud bursts now. So because of this, you have heavy discharge in sudden times. So amount, intensity, distribution, these are the three important things in precipitation that is important to look into. Then temperature. So global warming is happening, as you know. So evaporation and snow melting. These are two important things for looking into the discharge factor of a river. So higher temperatures increase evaporation rates, reducing available water for discharge as well, while snow melting is high at the same time. So if you see the river originating from snow, like Himalayan rivers mostly, you see river discharge is very high during certain time period. Then further you have vegetation. So infiltration and transpiration is affected by vegetation. It enhances infiltration, water uptake by roots, and moderating runoff and discharge as well. While evapotranspiration, if you remember, vegetated areas lose water through evapotranspiration, reducing runoff and discharge as well. Then you have the fifth and the last thing, that is human activity, us, human beings. So human beings do what? Urbanization, dam and reservoir construction, infrastructure creation, water withdrawals. All these are affecting the river discharge. So these are the factors consolidated at one point. Now let's understand finally the techniques of measurement of this river discharge. So there are numerous techniques. We have done here what? The major techniques, the most common ones that we are generally using, right? So first of them is velocity area method. As the name tells you, we need velocity calculation. We need the area of this cross section. So this is what two data is required to calculate it. So if you observe, this is one of the most common methods used to measure river discharge, right? And it involves two steps. What are the two steps? First, you have to have this cross section area, a point here, right? And along that, you need two things: current meters. These are devices which are placed here, right, in the water to measure flow velocity at various points. So if you see, if I divide this into several segments, at each point the velocity will be taken, and data from these points are used to calculate average velocity, right? Remember, the river will not have same velocity in each point, right? So that's why we will have to do this current meters. And then you have something called flow meters. These instruments provide direct measurements of flow rate. So there are different types of flow meters, including electromagnetic and ultrasonic flow meters as well, because of advancement of technology. And there is a equation that you see here. So Q is equal to A into V, where Q is your discharge, A is cross-sectional area, and V is average velocity, right? And remember, United States Geological Survey gives us a schematic diagram. So see here, selection. Remember, measurement of the area and selection is very important. So this is something where you see that a measurement section and a control section is given here. So channel should be straight and uniform where you are taking this measurement, this section. That's very important. And there is a scientist called Manning. So velocity calculation by Manning's equation is done many times. I've given you here Manning's equation to read for yourself. So you can pause the video here, and you can, if you want to note down, you can do it, or you can download the ebook from our website. You'll get this material itself. So I'm not reading this particular equation. Important is to look into that who was Manning, and his equation is used for this particular velocity measurement. So Robert Manning is person from France, right? And he's an engineer and a hydrologist, and he developed this equation during 1891. So it's an old, right, old age equation, and we solve it. So where average velocity, water surface slope, hydraulic radius, roughness coefficient, all these conversion factors are being used. Now, come to the next important technique which is commonly used. It's called acoustic Doppler current profiler, ADCPs. If you see some commonly used ADCPs here, RDI Stream Pro, RDI Rio Grande ADCP, Sontec M9, Sontec Mini ADP. These are used by engineers and hydrologists to look into, and it is based on what? Doppler effect to measure water velocity profiles. That's very important here. So advantages of this Doppler effect based machine is that it can provide detailed velocity profiles across river channel and can be used in various conditions, right? And this is very important for the depth calculation and velocity calculation both. Now, how do you deploy? It can be mounted on boats or fixed structures, allowing for continuous and periodic measurements, right? Then you have the third technique. It's called a tracer technique, tracer substance. Now the word itself is trace. What do you trace? So first you make a section where you dip this trace elements, right? So here this tracer substance is put in the river, and then at the other end it is now calculated. So tracer method is common tracers being used like dyes. So rhodamine, chemicals like salt, these are used, and the discharge is calculated based on known quantity of tracer and its concentration downstream. So X quantity is you're dropping here, and downstream you measure the quantity and then you look into it. So here the calculation is Q is equal to M by C into T, where M is mass of tracer, C is concentration of tracer at downstream point, and T is travel time. This is also called tracer substance method, right? Now let's go into the fourth important technique of this river discharge measurement, which is based on hydraulic structures. So we create hydraulic structures, engineered structures called weirs and flumes, right? So how does it look like? You see these weirs of different shapes here, triangular, rectangular, capillary. So you observe here, these are the fumes, these channels, and this is what you create, and then you measure. This is something where hydraulic geometry is also important. Hydraulic structure is important. So weirs are the barriers, right? And it's also called a head sometimes. And what is flumes? It's designed channels that force water to flow through a constricted section. So weirs and flume method, hydraulic structure method, remember this is also important, and you again have a calculation here. So Q, which is discharge, is CD into A root over 2gh, where CD is discharge coefficient, A is area of flow, G is acceleration due to gravity, and of course H is height of the water. So these are the methods you observe here. Fifth method is called rating curve method. As you know from the word itself, rating curve. So it's basically an empirical relationship between river discharge, that is water level, and remember discharge. It is developed by conducting direct discharge measurements at various stages and plotting these data points. So if you observe stage discharge relationship once established, rating curve, remember we have to plot and then we look into it. So here calculation would be A into H minus H0. So this is something where you observe H is the stage, H0 is stage 0 flow, and A and B are empirical constants. So these are all, remember, these are quantitative techniques here. And now in modern world, what do we use? We use remote sensing platforms for this. So remote sensing, that is satellite based and aerial photography based, can be used to estimate river discharge by analyzing the surface water extent, their flow patterns, hydrological characteristics. You can observe here itself, right? So this is which is used now commonly: UAV, drones, unmanned aerial vehicles. So you observe here advantages: it provides broad spatial coverage and can be used in inaccessible areas. Not all the river and stream is accessible, isn't it? And these techniques involve radar, optical, and thermal sensors to monitor river dynamics. Very, very, very important for disaster management, flood management. This is where it is used, right? So these are all the techniques. Now let's observe the classification of this river discharge. So the number one is perennial river. As we were talking about, that not all river would be coming from the snow melt. So perennial river characteristic is continuous flow, right? So if you observe Amazon, Nile, Mississippi in the world level, and here the Himalayan river system have a perennial flow, right? Intermittent river. Now the word itself is intermittent. They don't have a perennial flow. They have a seasonal flow. So river in semi-arid regions, they flow during wet season, and during dry season, this is water is only available in thalweg or sometimes even dry. Then you have ephemeral streams, flow only briefly during the rainy season, right? So what is in desert regions if you observe? Then look into the base flow, the portion of river discharge sustained by groundwater seeping into the riverbed. It maintains river flow during dry periods. So this is very important. And remember storm flow. We talked about this in hydrograph. So storm flow is because of the runoff during the precipitation events. So high runoff leading to high potential flows and potential flooding. This is something which is very important. And these days, a lot of flood risk management and infrastructure design is being kept in mind. You know, remember, river discharge is being kept in mind always. Now, look into some key terms. So hydrograph, flood, base flow, bank full discharge, peak rainfall, and lag time. These are some of the terminologies that you should not forget whenever you are learning this particular topic. So now that we have discussed the various aspects of river discharge in this video, I'm sure you have learned something. So please do share with others. And also in the next video, we are going to continue with this series. So about 5-6 more lectures are left. So we'll be covering each of them. So stay tuned, stay subscribed, and we would appreciate it more if you support us by joining our channel. So all the best wishes for learning. Take care. Enjoy.